Young's modulus of the wire depends on. So the first one is, what is Young's modulus? So Young's modulus is how can be defined? So Young's modulus, that is denoted with Y. Young's modulus is equal to, so longitudinal stress divided by longitudinal strain. So this is the ratio is called as Young's modulus. Okay, so this is the shortcut you have to stress by strain. So that is called as a Young's modulus. Now, so this Young's modulus is depending upon what are the factors. So the Young's modulus is equal to, so it is given by that is equal to stress, that is a force by area. Longitudinal strain means change in the configuration to the original configuration, change in the length to the original length. So this is the ratio is called as longitudinal strain. So finally we got the equation is, that is FL divided by A delta L. So now that is a Young's modulus is equal to F. Okay, we know that is a, according to the Newton's second law, that is F is equal to m into G. So when the wire is suspended with the certain weight with mass m, that is a m into G. So this is F is equal to mg. Now you have to put the value, that is mg L divided by, that is pi r square delta L. So finally we got the equation is this one. So now what are the factors of the depending upon the Young's modulus is depends on nature of the material. So this is a depending upon the nature of the material. Nature of the material of object or anything. Okay, so that is a nature of the material. So this is the answer for this question. Okay, so that is a nature of the material. It does not depending upon length, so it does not diameter. So material of the wire, nature of the material of the wire. So that is a option C is the right answer for this question. Okay, move to the a wire length L, radius R, rigidly fixed at the one end. Okay, so this is a wire, this is a fixed with the rigid is here. On the stretching the wire, end of the wire with the force F, the increases in its length is L. Okay, so now you have to stretching the force, how much? F. So it increases the length. So increases the length means, so that is original length is L, increases the length. So original length is L, that is increases length is equal to L, the force is F. So if another wire, same material, so this is important word, so same material but length 2L and radius is 2R. So initially radius is how much? So on stretching the end with the force F, the increases the length is L, radius is how much? Initial radius is R. So this one radius is R. So now in the second case, okay, so you have to come to the second case. So this is a same material, okay, same material. So but it is the force is how much? The force is 2F and original length is L. Okay, original length is L. original length is L. How much increases the length? The increases the length is equal to 2L and the radius is 2R. Okay, same material but the length, okay, sorry, the length is how much? The length is 2L. Okay, the length is 2L. Okay, that is a L is equal to 2L and radius is how much? 2R. So you had to stretch the force to F. What is the increases in the length? So how much increases the length? This is the question mark. So now you have to come to the first one. Okay, you know that is a Young's modulus is equal to, so that is force by area change in length divided by original length. So that is final equation is that is FL A delta L. So now you have to put the value, that is length is L, okay, that is A, force is F, length is L, then R, radius, you have to convert area of cross section into radius, that is pi R square. Then increases the length is how much? Small l. So then go to the second one. That is a y is equal to F. Force is how much? 2F. Force is 2F. Length is how much? 2L. Length is 2L. Divided by radius is how much? 2R, that is pi is as it is 2R whole square. So then you have to calculate change in length, that is a delta L is you don't know. So now finally that is a 4FL divided by 4 pi R square delta L. So now 4 get cancelled. So that is a y dash, second one, this is a y dash is equal to FL divided by pi R square delta L. So now it is a same material, means both the Young's modulus are same because same material. Okay, because same material. Okay, so now you have to put the value, that is a FL divided by pi R square L is equal to FL divided by pi R square delta L. So now FL cancel, pi R square cancel. The finally delta L is equal to, okay, delta L is equal to how much? Original length L. So now the increases in the length. So this one increases in the length is equal to how much? So that is a increases in the length. Okay, so that is a increases in the length is equal to how much? So increases in the length, that is a delta L increases in the length, that is a delta L is equal to L. So which option is right? So that is a option B is the familiar to this solution. Now this is the right answer for second question. The Poisson's ratio cannot have the value. So now the Poisson's ratio, the theoretical value of the Poisson's ratio, okay, the theoretical value of Poisson's ratio lies between -1, okay, -1, that is a Poisson's ratio, so it is denoted by sigma, so that is a lies between -1 to half. So then it is a practically it is lies between, okay, so practically this Poisson's ratio lies between, okay, so lies between, so 0 to Poisson's ratio, that is off. Okay, so now you have to look at the option. This is a 1/2 means this one is how much? This is 0.5. So this is also 0.5. So now that is the correct answer for this question. Is it 0.1? Is it 0.3? 0.7? Okay, so Poisson's ratio cannot, so 0 to 0.5 means this is 0.1, 0.2, 0.3, 0.4 up to 0.5. So these are the values of Poisson's ratio. So these values lies these values. 0.1 is right answer, 0.2, 0.3, that means sorry, this is a lies values, Poisson's ratio or lies. So this Poisson's ratio is the lies of these values. The question is asked cannot. So cannot means what? 0.7. That is a option D is a right answer for this question. Okay, so which of the following statement is correct? Okay, first one is shearing stress, there is a change in volume. So look at the option A, the shearing stress. Okay, shearing stress. So shearing stress, there is a change in the shape. There is a change in the shape. There is a change in the shape. There is a change in the shape without change in the volume. Without change in the volume. Then in the B, that is a tensile stress. So tensile stress means tensile stress. So tensile stress means there is a change in the shape. There is change in the shape. There is the change in the shape, but no change in volume. Okay, without change in the volume. Then C, shearing stress. You have already definition of shearing stress is, I wrote it here. Okay, then D option is hydraulic stress. So hydraulic stress means hydraulic stress. Hydraulic stress, there is a change in the volume. There is change in the volume. There is change in the volume. There is change in the volume. So without change any shape. Without change in any shape. So now you have to find out the answer. Which answer is right? Shearing stress, there is a change in the shape. Okay, shearing stress, there is a change in volume. Volume is does not change. Okay, so that is answer is this one option is a incorrect. Tensile stress, there is a no change in volume. Okay, so tensile stress, there is a change in what? Shape without any change in volume. Okay, tensile stress, there is a no change in the volume. Okay, so volume is what? Without, not for without. This is volume is change in the tensile stress. Shearing stress, there is a no change in the shape. Shearing stress, there is a change in the shape. No, it is a change in the shape. This is a volume is what? Volume is constant. So that is a two options are incorrect statements. Then hydraulic stress, there is a no change in the volume. Okay, so that means change in what? Hydraulic stress means change in the volume. So that means it is a change in the volume. So this is also incorrect statement. Now the answer for this question is, okay, answer for this question, which of the following is correct? So this is a B option is correct. Okay, so tensile stress means there is a no change in the volume. Okay, without change in volume. Look at this one, without change in the volume. So change in what? Shape. So that is a B option is a right answer for fourth question. A heavy uniformly rod hanging vertically from the fixed support, it is stretched by its own weight. So now this is called as a heavy rod. Okay, this is a heavy rod. So this heavy rod is its own weight. Okay, its own weight means that is W is equal to mg. So vertically the diameter of the rod. So now when the rod is suspended with with its own weight for heavy object, okay, tension is the tension or force, the tension or force, the tension or force, the tension on force is heavy at this hand, that means top of the rod as compared to the bottom. This is a bottom. Okay, this is a bottom, this is the top. So that means heavy force or heavy tension is here. Why? Because the whole load or whole heavy of the mass of the object is suspended with the top. That is the reason. Okay, the tension or force is more on the top. Okay, more on top as compared to the bottom of the rod. So now the load is more on the top means it is the diameter is less. That means, okay, the diameter of the rod is less as compared to the bottom, like that, when it is own weight is suspended. Okay, so that means which is the answer? Smallest at the top, diameter means radius is less. Okay, smallest at the top gradually increases down on the rod. Okay, so now the radius, that means diameter is less. The diameter is less on the top, gradually increases. Okay, so that means this is the answer is right. Largest on the top, no. Uniformly everywhere, no. Maximum at the middle, no. So that is a option is the right answer for this question.